All right, everybody, welcome back. So yeah, let's take a look at where we are and discuss the agenda while we get some more time for others to join. So we are quickly approaching the end of the semester. Right, we are focusing this second half of the semester to deal with the back end part of our application. Right, we're implementing a client server application. We focus the first half of the semester mostly on the front end, and the second half where we introduce first the implementing a Node HTTP server, and then for the last week or so we've been discussing adding the last piece of this multi-tiered architecture, adding a non-relational database, right, MongoDB. I've been sharing the source code for all the tiers, and you should feel free to use all that source code for your own purpose, for using it to complete your assignments, and now use it for your own project, right? In the last lecture we discussed how to use a database to manage users, create accounts, be able to sign in, sign out, sign up, right, and view the currently logged in user. And that is one of the main requirements in the project, right? That folks should be able to authenticate themselves, create accounts, come back later and view their own profile. So we implemented that, I believe, last lecture. So I shared the source code. Please feel free to reuse that, not only to complete the upcoming assignments, assignment 6, but as well as implementing the requirement for the project. All right, so take a look at that, and you can take that directly and use it. Oh, it's okay. So the quiz. Oh, all right. So I'll change the quiz due date to be a couple more days. Yeah, not just 2 days. So I'll give it a couple more days. So yeah, so today we're going to expand on what we've been working on be able to authenticate, right? Since our last implementation was based on keeping track of a single variable, right, of someone logging in, and the server stores that person as the currently logged in person, right, the current user. And that solution only allows one person to be logged in at any one time, right? So that solution doesn't scale very well. So today we're going to introduce a technology called Session that is built on top of cookies, right? That is going to allow, right, for us to maintain multiple users, multiple separate sessions, right, simultaneously, right? So we can have instead of just one person, we can have a dozen, hundreds, thousands of people logged in simultaneously. So we'll discuss that, as well as I'd like to go over the assignment 6, the last assignment, and hopefully you'll find that we've already covered a lot of it, right? Of which I am sharing the source code with you, and but there are a few other little bits and pieces that I want to go over. In particular, being able to support multiple users. Okay, so that's the plan for that today. So yeah, the assignment is going out today, and it won't be due for the next 2 weeks, right? So two Mondays from today, which is after the Thanksgiving break. So also this week is Thanksgiving break, so we're going to not have a lecture the second half of the semester of this week. When we come back, we'll keep working with on the project, with adding implementing more of the requirements, so you can have an idea of what they're all about. The second week in December, the project will be due, of which you will be demonstrating your project to TAs, right? And we're basically just going to ask you to demonstrate your own project, right? So it's not like we're going to try and break your project, right? So it's you using your project, and you can you will be asking you please demonstrate that you can log in, right? That you can create a new account, that you can modify your account, that you can search for data from a third-party API, that you can show the results, that you can go and view more details about a particular object, right? That you can see other people's relationships with these objects. You can't see my screen? Oh, maybe I haven't shared. Yeah, can you see my screen? Okay. So yeah, so then the exam will be the last week, the week of the 11th. So not on the 15th, right? It'll be available from the 11th for several days. On the 15th, that's for the undergraduates. They have the exams on that particular day at that particular time. Everyone together. But the online courses, right? The exam is available for several days online. Okay. So anyway, so that's the plan for the next couple of weeks. Any questions? All right. Hold on a second. Okay. All right. So yeah. So let's see. Let's go over the latest assignment. We've already peeked at this through the last week or so, and so let's see how far we've gotten already. Right? We already discussed the overall architecture of what it is where we're building. Right? That we have the React application as the front end, and we focus our attention to the node server all the last 3 weeks thereabouts, right? And then recently we added our third and final layer, the data layer, that we're using as a permanent storage solution, a Mongo database implementation, right? We implemented the schema, a model, and we focus our attention on working with user schemas, right? And user models and user collections, so that I can discuss the topic of how to manage users, how to create accounts, how to log in, how to register, and things like that. Yeah, so we installed the database, either as a service on Windows, or you can run it manually, right, from the command line. I've been running it from the command line. I think I already have it running somewhere. Where is? Oh, there it is. Well, I guess not. And so we can run it here. We can go to user, local. Under bin, we have MongoD, and we can tell it to use the data directory, right, to store all its collections, right, in that file system. And so what else? We so yeah, you can either provide or create an environment variable that contains the location of the executables in your bash profile or your environment variables in Windows, right? Just to make it more convenient to start MongoD, right, from the terminal. Or if you know where it is, you can navigate there and run it from there. But that's only for convenience. We then connected to the database using Compass. So Compass is a user interface that part of the same family of products that allows us to interact with the database manually. So here it is. We connected to the database, and we were using, I believe, this one, where we created several collections, right? The users, assignments, courses. I did provide sample data for you for courses, modules, users, assignments that I ask you to import, right? I demonstrated how to do it with users.json, and we loaded up a whole bunch of users and courses. And then I demonstrated how you can interact with the database locally. This is on Canvas. It shows deadline for quiz 4. Yeah, no, somebody already asked that. I will extend that. So I made this optional. If you want to practice working with the database manually, you don't have to, but it's a good skill, right? To pick up, how to interact with the database manually. It also sets you up for your expectations when you interact with it programmatically and says, oh, okay, so I did this manually. I can also do it programmatically, right? You can also interact with the database through a VS Code plugin, right? Again, that's optional if you want. If you prefer to interact with the database graphically from within code. But the more interesting part is that we are able to interact with this programmatically. So we installed a library called Mongoose, right, that allows us to connect to a database from our Node.js server. Right, we installed it, we imported the library, and then we use this connection string, right, to connect to the database that's running on 127.0.0.1, right? And this needs to be the IP address, not local host, right? So careful. Then we implemented schemas, right, that allowed us to describe the data structure, the collection that we were connecting to, specify exactly the collection name, right, which we had already implemented in the database, and then implement a model based on that schema that provided all the low-level generic functions that allowed us to CRUD all the data in the database, right? We then wrapped that low-level model with a higher level set of functions, right, with an API of our own that was much more specific to our purpose, right, of dealing with users, creating, reading, updating users, right, that allowed us to interact with the database, and then we implemented a RESTful API, right, that allowed us to make all this functionality available to clients, right? In particular, our web client that we've been building in React.js, but really anybody who can establish an HTTP request, right, to this server can interact with the server, right? Doesn't need to be our React web app, okay? So we implemented that. And so notice that we have this doesn't show the actual implementation. Later in the assignment, I ask you to implement each one of these, one at a time, as we build various features of the application. In particular, all the authentication portion of the website, right? That I want to be able to sign up for an account. I want to be able to sign in later on tomorrow. I want to access my account. Right? You want to see my account, right? And then eventually I want to sign out, right, and cancel what I'm doing. And then I've made the routes available in the app.js. Okay, so each one of these, the assignment goes through each one of these and implements them in the next several sections. So for instance, here would implement first signing in, right? I'm going to be able to provide my credentials, right? And the database and the server is going to look me up in the database. If it finds me, then they're going to make me the currently logged in user, right? The current user. So yeah, so in the database we already have this. We gave you that. And then in the routes, right, we're going to use that database, that DAO implementation. We're going to first extract the credentials from the body, right, the username and password, and then we're going to pass them into the DAO function, which is actually going to fetch this from the server. Then does this user exist? If they do, we're going to store it in this local, right, variable so that we can remember, right, who is currently logged in. So that in subsequent queries, right, if we ask, okay, give me the account information, we can retrieve it and we're going to respond with that current user. Okay. So meanwhile, on the client, once we make the route available, right, at a particular endpoint, HTTP endpoint, now we're ready to start communicating with it from the client, from the browser. And so here it is. Here's our Axios invocation for sending our posts to send the credentials to the sign-in, right? That needs to include username and password in there, right? And then we can use it in our front end, right? So that we can capture the username and password here in the form, and then when we submit, right, we can send that to the server, and the server receives the credentials, and if it's successful, then we navigate to the account screen, right? So meanwhile, when you get to the account screen, we need to be able to access our account information, right? So for that, right, we implemented an account route, right, that when you query it, it responds with the currently logged in user, which was set in our prior sign-in screen, right? The sign-in screen sets the current user, and then when we navigate to the account, it's going to go fetch the current user from here. So from the front end, right, we implement the reading of this from the server, right? It's going to post the account so they can return the account value. And if it's successful, right, and what we're going to do is that we're going to, when we navigate to the account, we're going to fetch the account and populate the local form, right, that with the account values, and we set all the account form elements down below, right? So yeah, so all that we worked on already, right? We already have this, and we are almost like halfway through the assignments, right? So this one should be a pretty easy one. So anyway, once you get to your account, since it's your account, you should be able to edit your account, right? So we implemented on the server an update user DAO function, right, that received the user in the body, right, and then passed it here so that we can set the new values with the updated values that you pass in, right? From the and then the route, right, use that update, right, to pass in the changes from the body parsed from the client. The client's filling out the form, they're changing their email, they're changing the last name, they're changing a whole bunch of stuff, and they send and they post or they put all those changes to the server. The server receives it here as a put. There it is, right? And that those changes are available in the body, which we pass into the update user, which is going to set that user's ID, right, the value to the parameter that includes in the body, right? We read the new user, right, from the database. We just set it. We just updated. We're going to reread it back into memory, and we're going to set the current user. Right, we're going to update it so that it includes the very latest values, right, for all the fields in the current user, and we just return status. Meanwhile, in the client, right, we're going to implement the update user that is going to send or put the values to the server so that it can modify the values of the fields that we updated, and then we're going to invoke that that update by clicking this save button, which is going to invoke the client update and pass in the account. So then we took a look at implementing kind of like a listing of all the users, right? Implemented using this DAO function, find all users, which is it's a wrapper around just model.finds, right? Which returns all the records. Now, so probably this is a little bit unrealistic, right? That we're going to ask or retrieve all the records in a database, right? First, I mean, if it's just for something simple like what we're doing, where we only have a couple dozen users, that's fine. But in reality, when you're in production, this really doesn't scale very well, right? Because the users could be hundreds of users, thousands of users, millions of users, right? So retrieving a URL that is going to return every single record in a form is somewhat unrealistic. A better implementation of this might be where you also provide a pagination, right? Where you can provide, I'm on page 2, page 5, 10, 20. And then, implement it so that you only retrieve like 100 in each page or something like that. That would be a much better implementation. But, we didn't do that. Then on the clients, right, we can hit that endpoint and retrieve all the users and kind of like display this table of users where you have all the columns are the various fields, right? And then we can navigate there from, say, in the account. Once you log into your account, you would have a link to all the users. This too would be probably unrealistic. More commonly, you would only have access to a link to all the users if you were maybe a system administrator, but not a regular person, right? So don't implement that in the project, right? The project should be realistic use cases. So a better implementation might be that I first check to see your role. And if your role is a system administrator, then yeah, by all means, go take a look at the list of users. But if you're a regular user, right, you're not an admin, then you should not get that link. Okay. We then explore being able to insert new records into the collection, right? And we created a route that we could call the create user DAO, passing as a reference the request body, which is going to contain the fields that were filled in the user interface, right? And once it gets instantiated, we just respond with a brand new user. On the client, right, we're going to add a new button, right, to create, which is going to invoke this RESTful API that is going to send this new user, who's going to post this new user, right, and send it over to the server so that the server can insert it into the database. So locally, we're gonna create a little form that we can fill out, username, password, first name, last name, various fields of the user, to which when we click on create, right, it's going to send this new user to the server, and the server is going to respond with the new user that was created, and I'm going to append it right to the beginning of the array. Down below, the first row, right, in the list of all the users, we're going to put in there multiple form elements that the user can use, the system administrator can use to, create new users in the system, right? Like this. So we would have two input fields for the the username and password, right? And then initial values for first name and last name, whether they were faculty, and then we pass it on to, when we click on plus, right? We post it to the server. The server then inserts it into the database, and then we see the new record being inserted into the database. Then we a few more of retrieving users by their ID, right? So that we can edit them, and then another one where we can delete, right? Click on delete. So basically all the CRUD operations, right? So we then implemented the sign-in screen, the sign-up screen, and the logout screen. And where I want to be today is I wanted to take a look at supporting more than one user, right? Our implementation right now only supports one user at a time, right? Okay, so how do we do that? How do we support multiple users? So the challenge we are trying to overcome, right, when we talk about multiple users is that the HTTP protocol, out of the box, the HTTP protocol is stateless, right? And stateless meaning there is no provision in the HTTP protocol that Tim Berners-Lee developed so many decades ago. There's no provision, or there was no provision for the server being able to distinguish one request from another, right? And the problem is that as we've implemented more and more complex applications, we do need to, sometimes we do need to distinguish one browser versus another, right? For instance, if you have one server which is it's implementing a shopping cart, say, right, for a store, and you have multiple users, right, each person having their own shopping cart, you need the server, all that data is being stored in the server, right? The server needs to be able to send Alice her shopping cart and send Bob his shopping cart. So it needs to be able to distinguish who's who. And the default, the basic HTTP protocol, when it was designed so many decades ago, had no provision for the server to be able to distinguish a request coming from Alice from a request coming from Bob. Okay, so in the early 90s, they came up with this idea of cookies that basically allowed, it's an addition to the protocol, the HTTP protocol, that basically if browsers and servers can agree on a unique token that that the server can generate, right, and then the different browsers can take this token, right, and if they want to be identified, then they would have to provide this token back to the server, so that the server could keep track of the various tokens and say, oh, this is the Alice's shopping cart and this is Bob's shopping cart, right, based on this token. Now that I can distinguish who you are, I can now write code around knowing who you are, that we can store things for you, or we can store things for someone else. Okay. So let's see how this works, right? So say here's Alice, and she's visiting acme.com for the very first time. She's she types in her browser acme.com, boom, enter. And so if the browser has agreed to participate in the cookies protocol, right, meaning it's going to provide tokens to the server identify themselves. If they participate, right, because folks can turn off cookies, right? You have to have cookies on and accept them too. So what the browser does when you say acme.com, the browser first checks to see if there are any cookies for acme.com, right? So it has a database stored in the file system, the browser, that uses the domain as the key, and then the value are the cookies for that domain. And so it searches for the cookies. It says, are there any cookies for acme.com? No, sorry, I don't have any cookies. So nevertheless, the request goes out to the server without any cookies. And so the server interprets this as this being the very first time that this person has ever come, right? Again, the server is kind of like an amnesiac, right? Where it totally forgets. Even if you've come to this server millions of times, there's no way for me to know that it's you again, right? So as far as the server is concerned, you're here the very first time. So what the server does is that it wants to invite you to participate in a collaboration, right? Where you're going to keep identifying yourself, right? That it's you again. And the way I'm going to distinguish you from someone else is that I'm going to generate a unique identifier cookie, right? A token, the unique value that I'm going to send to you in the headers, right? In the HTTP headers, I'm going to send you, here's a cookie. Please store it for me. Keep it stored in your browser. Right? And so that's what the browser does, right? Again, if the browser agrees to participate in cookies and you say accept all, right? It saves the cookies in the cookie jar so that in subsequent queries, it can find it again, right? So now what the server does is that when it creates the token, it also maintains a data structure where it keeps track of all the tokens that it has created so far, right? And it needs to purge it after a while, right? They time out, right? And so they clean up and whatnot, but that's something else. So what it does is that it uses this cookie that it created, this unique identifier, and it uses it as a entry key to a data structure called the HTTP session, right? That what it's going to do is that for every unique cookie, right, it's going to create an HTTP session, right, mapped to that one cookie. So that, if Bob comes in with one cookie, then Bob has associated an HTTP session. If Alice comes in here and has a cookie, then she's going to have an HTTP session associated to her cookie. Make sense? So every cookie is going to have a different HTTP session instance, right? So next time around, after having accepted the cookies, right, and you come back the second time around, the browser this time is going to go to the cookie jar and is going to find the cookie down, right, for acme.com. Says, oh, look, now I have a cookie, right? And so again, if you accept all, right, all that, then the browser grabs the cookie and sends it over to the server, right, along with the rest of the requests. All your requests goes in, right? And so now the server says, "Ooh, you have a cookie. Great. Before you didn't, but now you do." And so what it does is it says, "Okay, well, first it validates that it had created it, right?" And it says, "Ooh, with this cookie, I know I had created an instance of the HTTP session for that particular cookie, right?" And what it does is that it grabs that HTTP session and it passes it to you in your code, right? In your code, you have access to that session object, right? And which will be different for Alice, it will be different for Bob. But that's irrelevant. For you, you get the session for that cookie already, right? And now you can write logic around that, right? You can you can write that, in that session, I want to store each person's cart, right? All the various books that you have been adding to your cart. Alice has her cart, Bob has his cart, right? And so, and I can store all this data in the session, right? But then if it's Alice that came through, by the time I get this session, it will have already been, dereferenced, and now I get Alice's HTTP session, and I can store, right, in her cart, right, the books for Alice. Now, if it's Bob coming, that HTTP session is going to be, it's a different instance, right? It's a completely different instance, one specifically for Bob, based on his unique cookie. So when I get the session, right, and I modify the cart, it's Bob's cart, not Alice's, right? So in that way, we can, deal with various data structures based on the cookie, right? So anyway, so how do we work on this? So sorry, where does a cookie and session store in browser? So the browser has a local database that it stores in the file system, right? When you install your browser, it has its own directory structure, right, where it keeps all that in its file, and you can see all the cookies. You can go to your session, your settings. Where's my settings? Oh, this changed a lot. What the UI changed quite a bit. Now I don't know where anything is. Yeah, you go to settings, right, and you can go to your cookies, where it has a local file system where it stores all these. And so your site settings, to results, third-party cookies, privacy, clear browse. Clear browser, I don't want to clear it. Privacy guide, third-party, speed, site settings. Cookies. Clear, privacy guide, third-party cookies. Site settings, security. What's this? Add topics. Add privacy. Anyway, it's local here. You can clear it. You can throw away. Like I have, a lot of cookies in here. You can go one by one, right? One of these, and then just throw away all those cookies so it doesn't remember anything. Cookies are stored on the browser. Yeah, no. So the browser remembers the well, both of them remember. So the browser remembers the cookie that was created for the domain. So it knows that Wikipedia has its cookies, right? And CNN has their cookies, right? And Facebook has its cookies, and Twitter has its cookies, and whenever it goes to visit those websites, it sends the cookies that it had stored for those domain and sends them to that server, and then that server uses those cookies to look you up, in the data in the server's database, right? And reload your session from the database, right? It says, oh, I have this cookie. Now I can reload your shopping cart. I know who you are. Once I have identify you and I know your identity, I can look up all the information that I had stored for you, right, from your user ID. Okay. But yeah, no, it's stored in the browser, and we send it over to the server. So all right. So let's continue. So how do we turn this on? How do we use it? So the way we use it is that we're going to first, install the on the server, we need to be able to support cookies, and on the client, we need to be able to support cookies, right? So on the server, to turn on the use of cookies and sessions and all that, we're going to first install this library called Express Session. So let's bring up our code. And so let's bring it up here. So this is going to be our server. So let's open recent, sign in to GitHub. Yes, absolutely. And let's bring in CS5610, Node.js. No, this one, okay. So in here, let's see what branch are we in. Okay, and let's go to, wait a minute, let me add this. So let's check out A6, right? And in here, let's install Express Session, okay? All right, so we install that, and so now, once we've done that, we can load the library in app.js so that we can configure our cookies. Okay, so let's turn that on, and let's bring in our app.js. So here at the top, let's import the session, and then course we're going to configure. Now this is very important that it has to be in this order, right? Otherwise it won't work. Notice how we instantiate app express, right? We configure course, and then we configure express JSON. So these two need to be in that order: first course, and then express JSON, right? In that order. So course opens up the requests, right, to anyone, right? Even if they live in a different domain, right? So a browser that is running on Netlify, that's fine. You can talk to me even though I'm running on AWS, right? And once that's open, then we are parsing from that request, we're parsing JSON objects in the body, right? But if you reverse this, I'm going to first try to parse something that doesn't have access to me, right? I'm going to fail. I'm not going to be able to parse it, right? So it needs to be in that order. So now we are going to add an additional thing. What we're going to do is that our new library is going to receive all the requests, right, from the client, from our browser. The browser is going to be sending requests, right, and including those cookies in the request, right, that the browser is storing for me, for my domain. And so first it has to get past course, right? So course needs to go first. And then the second thing is that once it gets past course, now I'm going to look up for the headers where the cookies are, right? And I need to parse those cookies. Sometimes the cookies are coming from Alice, sometimes they're coming from Bob, sometimes they're coming from a whole bunch of places, right? And for each one, right, there's coming, or each of the cookies, I am going to instantiate an HTTP session, mapped to the particular cookie coming from different places, yes? Once I instantiate the HTTP session, right, I pass it to you in your application, in your code, in your routes, right? When it hits your route, right, I will pass you the session object so you can store in there whatever you want, right? You can store a cart, right? And so if you manipulate a cart in the session, it'll be Alice's cart, right? If it's Alice's cookie. But if it's from Bob, right, you're going to be manipulating the data structure for Bob, right? And so as they come in, right, I am manipulating somebody's data structure, somebody else's data structure, somebody else's data structure, because they're all mapped to different cookies, as they come in. All these cookies are unique. So let's configure the session. And so first of all, what we're going to do is that because now we are going to introduce authentication the right way, right? Using cookies. Before we were just toying around using just a simple current user, right? But in reality, right, we need to use cookies. The cookies need to be protected, right? They need to be encrypted. And so we're gonna tighten up the access point a little bit, right? So first of all, we're not just going to accept requests from anybody. We're gonna say, well, I'm only going to accept authentication, right, from a specific source, from a specific origin, right? Not just from anybody. I'm gonna be strict now about localhost 3000. Right? I'm also going to turn on cookies, and the way we turn on cookies is turning on credentials. Credentials true. Right? So let's do that. Let's copy that. So in our course, we're gonna paste that object, right? That's gonna configure course. Be a little, more careful where it's receiving its requests, right? Not just from anybody, but specifically from this particular URL. Okay. Once we've done that, right, after doing the course, which we've done, we're going to configure the session. We're going to configure the session. So this has to be after we do the course, but before we get to JSON, right? The parser. So it needs to be right here in between. So I'm going to paste that. Okay. And so there are a few things. We're going to say that one of the things I would like to configure in particular is this secret here, and that allows us to deal with folks trying to steal our identity, right, using cookies, right? Because so your connection from your browser to the destination server, right, goes through multiple hops of servers, right? And so anybody in between could be listening and seeing the traffic go, from my browser to the destination, and part of that communication might include cookies, and cookies are used for identification, right? To know that it's you. So anybody in the middle could grab that cookie and pose as you, right? That maybe you logged into your bank account, you logged into somewhere, right? And I can take that cookie that the server and you have been exchanging, right, to authenticate, and I can grab that and then pose as you. So for that cookie needs to be encrypted in such a way that even if you catch that cookie, right, you don't even know what it is, right? You won't have the public key and private key to be able to decipher the cookie, right, and be able to sign, right, the cookie or the messages that go between the client and the server. So even if you get the cookie, it's irrelevant to you. It's not useful. So you typically you use a secret here, a piece of text that you would not include in your source code. You would include it as an environment variable outside, right? We're in a protected environment, right, in a file system. And this string would be used for signing and deciphering the cookie. It could be any string as long as it's secret. Nobody knows what it is. Okay. So anyway, so once we've configured the session, we can tell Express, right, to use this in every request that comes in. Right, to parse the request, parse the cookies in the HTTP headers, right, and instantiate an HTTP session object from that cookie, right, and make it available, right, in the requests, right, when it reaches your routes. Okay. All right. So once we've done that, that's great. So now we need to, now that we do that, now that we have sessions, we can now go back to our routes, right? And instead of using this, this current user, right, variable, we can instead use this session object, right? So so this current user is the same object for any users, right? If Alice comes in and Bob and right, and if anybody comes in, you had 10, 20, 30 people, right now our implementation would be using the same current user object for all of us, right? Instead, we want one object which is different for each user, right? So we want one object. We want one current user for Alice, another current user for Bob, another current user for Charlie, and whatnot, right? So how do we do that? Well, now request has a new property in there, right? Well, right now it has params, right? It has the body, right? So the request contains all this stuff that is coming from the request, right? From the params coming from the URL, the body embedded in the message, right? But now also we have session, and session is tied to the cookie in the header that also comes from the request, right? So that gets converted into a request object that gets passed to you. And in there, you can put whatever you want. We are going to use it to be able to put in the current user who's logged in, right? So that when the cookie comes in, I can say, oh, who's logged in for that cookie? For the Alice's cookie, who's logged in? Oh, Alice is logged in. You know, from Charlie's cookie, who's logged in? Oh, Charlie's logged in, right? And so now they're not going to trample on each other, 20 people using the same object. Each one's going to have their own version of the same object, right? So we're going to replace everywhere. Any use of the current user, we're going to replace it with this new session, right? So there it is, current user. Now current user becomes a local constant, right? And so what we were doing here, we were storing the user by ID. We were storing it in the current user, right? And which was one current user for everybody. But now I do have one place to put it that is specific to Alice, Charlie, Bob, and that's in the request session, right? In here, I can store whatever I want, you know, and I can give it it's like a hash table. It's like a map, right? I have a key, and in that key, I can store wherever I want. Right? So I'm going to use as key, I'm going to use the same name as the variable. It doesn't have to be, as long as you're consistent and you know where you put it, right? As long as you know what the key is, you can always put it there and then get it back if you remember what the key is, right? So I'm going to put it in the current user in there so that in subsequent queries, I'll have access to the current user, right? Because I know where I put it. I put it in there. And so let's continue. So here, again, we are retrieving the data, a user from the database, and we're storing it in this local constant, right? And again, I'm going to store it. So every time we're moving data from the right to the left, we are setting the current user. We're going to do the same thing with the session object. So this new object, again, Bob is going to have a version of this. Alice is going to have a different instance of the request at session, right? Charlie's going to have another instance, completely different, right, of request at session, right? And it's mapped to their cookie, right? Different cookies, different sessions. What else? Another one. Here we want to destroy, right, the current user object. We're making it null, meaning we want to forget who's currently logged in, right? Because you're signing out. So anything associated to you, I don't want to remember. I want to destroy that. So what we could do is we say request session destroy, right? And we don't need a variable for that, right? So now we've forgotten anything you had stored in there, shopping cart, right? Your preferences or anything you had stored in there that you wanted me to remember in the session, right? It's all gone, right? And another one in the account. And so in this one, we want to be able to send back the current user that we had stored earlier, right? But we're no longer storing it in the global current user. Instead, we're going to have a local current user constant, which I'm going to populate from the session that is remembering the current user, right? Now it's a read operation. Now we're reading from the session. We're storing in a local constant. Before we were putting stuff in the session. Now we are reading from the session. And that's the point, right? When we sign in, sign up, when we write into the session because eventually in the account, we want to read from the session, right? To remember who was the current user. And that's it, right? So that's on the server side. Now, okay, we've configured the server to work. Now we have to do the same thing on the client. The client also needs to be configured to use cookies. By default, the client, the browser, right, doesn't use cookies, right? So we need to turn that on and configure it correctly. So let's do that. So we'll need another window here. And we'll load up the CS5610, the React. There it is. And let's put it over here. So in our client code, right, we are using Axios as the library to talk to the server, right? And by default, git branch. Oh, this is my confirmation. Git add. Let me get to check out A6. A6. Huh? Okay, git checkout. Git branch. They don't have a project. Oh yeah, project. Git checkout project. Yeah, that's where we were. Okay, so back in the right. So in the project, we had the users, we had the client. So the client is using Axios to talk to the server, right? To sign in, to get the account, to sign up, right? To sign out, right? All the various create new users and whatnot. But now we wanted to do all those operations within the context of having logged in and signed in, and I'm looking at the account. But instead of using that fake, current user variable, we want to use the cookies, right? For it to remember who we are, right? So by default, Axios doesn't use cookies, right? If the server tells it, hey, here's a new cookie, Axios is not going to know what to do with it, right? So it needs to be told, yeah, participate in the cookie protocol. If the server tells you to please store this cookie for the server, right, in your domain, do that. Also, next time around, when you hit the same server, look into your cookie jar, see if there's any cookies for that server, grab it and send it over to the server so that the server can authenticate you and know it's you again, right? By default, Axios doesn't do that, right? So we need to create an Axios instance that is going to allow us to do that, to participate in that cookie conversation, right? So to do that, we're going to create a local a constant, right, that is going to create a new instance of Axios, which is configured to use cookies, right? So by default, it's not. So to do that, we use a property called with credentials, right, which turns on cookie support, right? This property turns on the feature of participating in the cookie transaction, right? Of, if the server sends you a cookie in the HTTP headers, right? Then store that cookie for Acme or for abc.com or whatever, right? And next time around, when you
are talking to the same server, grab those cookies and send them over, right? By default, it doesn't. So but now this request is the same as Axios. It's an Axios instance, but it's configured. It has certain configurations. So what we're going to do is that wherever I want to talk to the server, but I don't care about cookies, I can just use the basic Axios, right? That's fine. But if I do need to participate in the cookies because I want the server for you to remember who I am, then I need to use this new version, right? So just to keep it simple, I'm not going to make a distinction of when do I need to know and when do I need to know. I'm just always going to use the same instance. I'm going to use just request all the time, right? Whether I need to or not, it's irrelevant. I mean, there's no harm in always participating in the cookies, right? It's just an extra line in the header, right? So I'm going to copy that. So I'm going to replace every single Axios, right, with the new instance, so that now cookies are going to be exchanged, and so the server is not going to be able to tell who I am, right? All right, so let's try this out. So on the server, let's start the server. Nodemon app.js. And here we're going to start npm start. Okay, so let's log in, right? First, we'll log in with Chrome, and then we'll log in with a different browser, right, to illustrate, right, that we can maintain both sessions simultaneously. Okay, so let's sign in here. I don't remember who we have, so let's go to a database and see what we have in users. So do we have Alice in here? I don't remember if I had created Alice. I guess not. All right, it's fine. So yeah, so let's log in as a Latin. Let's copy this. Let's see, username and the password. Password, right? And say sign in. Okay, there's a Latin. Save. And so notice if I refresh, it's going out to the server to fetch the information, right? So in a separate browser, now it has to be a different vendor, because if it's the same vendor, they all share the same cookies. Right? So I'm going to use a separate vendor, maybe Safari. All right, and like that, and I'm going to bring that over. I'll put it next to here. And let's navigate to same localhost 3000 and refresh, right? So let's sign in, and let's sign in to someone else, right? And so let's log in as Nightly Storyteller. So let's do username, copy, and paste. Oops. And then the password. Oops. Paste that in there. Sign in. Okay, so now on the right-hand side, I'm logged in as Nightly Storyteller. If I refresh, notice that it remembers that this is this person, right? And on the left side, notice if I refresh, it still has its own session, right? So the current user on the left side is being stored in one cookie, one session, for that is tied to that cookie. Whereas on the right-hand side, right, the current user is being stored in somebody else's session, right, tied to a different cookie, right? And you can see the cookie if you inspect here, right? In the request, in the network, right? If I refresh and see in the account, in the headers, you can see the cookie. See, it says cookie right here. So this is a cookie that is being generated by our Node.js server. And if we inspect on the right-hand side, oh, this is Safari. I don't know where it puts the cookies. Let's see if I can find it. Audit layers, graphics, storage, maybe. Local storage, cookies. There we go. So we click on cookies. So yeah, there it is. There's cookie. The cookie's name is connect.sid. So this one is also connect.sid. See that? Equals and then the string. So this string needs to be different than the string over here. Right? So these are unique values. I guess I can't see it. There it is, right? So there it is. So you can see that this ends with 7LOTW, whereas this ends up with CTH7JC. It's different, right? And so they're different cookies, and so that cookie is used to instantiate different sessions for each different user. Okay. What was that? I can't distinguish between cookie and session. Are they like key value pair? No. So the cookie is just a string. Cookie is only the strings, right? The server for each string, right, for each cookie, right, creates an HTTP session. Well, only for that specific cookie name, right? Cookie connect.sid. It's looking for that a cookie called connect, because you can have a whole bunch of cookies, right? But the server for dealing with the session only looks for that particular cookie. And once it receives that cookie, it maintains a data structure where it has a whole bunch of session objects in a table, right? And the key to that session is the cookie. Right? So you take the cookie for Alice, right? And then there's an HTTP session object instantiated for that cookie. If you take Bob's cookie, right, it'll be another entry in the table, right, or in the hash table, and there'll be a different HTTP session instance. Okay, and that, so when in your URL, in this URL, when you're retrieving the account or setting the account or signing in, the cookie is sent. The cookie is sent, right? And so the value of the cookie is used to find the instance of the HTTP session. So when your URL is handled by a route, in the route, you will get in the request that session object, right? That is the HTTP session that was found for that particular cookie, right? So for Magic Lamp Seeker over here, right? He will get a different request that session instance than Nightly Storyteller will get a different request that session instance, because they have different cookies, different entries into the table. That makes sense? Okay. Yeah, that's all. That is maintaining sessions and maintaining multiple users. All right. So I'm going to commit this and push it. And again, feel free to reuse this for implementing the requirement in the project that folks, you have to have multiple users supported, right, simultaneously. You can have any number of users now logged in, each one with its own HTTP session instance. Now, in general, we try to avoid storing too much information in the HTTP session, right? Because we are now asking the server to remember something specific, an object instance for each user, right? And that instance object is being instantiated from the server's memory, but the server only has so much memory, right? So you can imagine that if you have hundreds, thousands, millions of users logged in simultaneously, it'll have to instantiate an HTTP session for every single user that is logged in. Well, so that could be very expensive, right? Memory wise and computation wise. So as much as possible, we try to reduce the amount of things that we need to remember about users, right? So we say that as much as possible, we try to make our application stateless without having to remember anything, right? And we try to, as much as possible, push any session management to the clients, to the browsers, right? Because there's millions of browsers, each one with its own CPU, with its own memory. So if we could offload as much as possible off to the browsers, then we don't need to demand so much of the servers, because there's always going to be many more browsers than there are servers, right? You only have a few servers, a couple dozens, hundreds, thousands to deal with millions of people that are hitting the servers, right? And so you always have to try to maintain the footprint of the server as small as possible, right? And because it can be flooded. Also, these sessions, which are instantiated on the server, right? They're occupying memory on the server's memory heap, right? And so they are they only have a certain amount of time to live, right? So there's a timer that starts, right? Once this HTTP session gets instantiated, a clock is running for each one of these sessions that eventually they're going to time out. And so the server can then clean up those sessions that have past due, right? Where somebody might have logged in and then walked away from their account, right? And they did not log out explicitly. If they log out explicitly, right, we can just throw away the session from memory. Right, we destroy, HTTP session destroy. That means that it can be garbage collected, right? Memory can go back to the server. But oftentimes happens that folks log in and they don't log out, right? And then they continue elsewhere. So the server is stuck with this HTTP session instance in the memory, which is useless. Nobody's using it. So there's a configuration that sets up a timer of how long the session has to live before it gets timed out, right? And so so that clock gets reset every time there's a new request for the same cookie, right? If it's the same cookie, I'll reset the timer for that particular session object, right? But if it happens that every 10 minutes I can check to see what sessions are out there that haven't been used for more than 30 minutes, and if so, just time them out, clear them, destroy them. People will have to log back in, right? Because if you use a cookie, because the cookie is still stored in the browser. So if you use a cookie that is stale, a stale cookie, right? That I gave it to you 2 hours ago, but the session was only allowed to live only half hour, then you're using a cookie that is no longer valid, right? And so I'll fail it and I'll give you a new cookie. I'll give you a brand new cookie, and you have to log in with that cookie. Also, cookies can be configured never to die, right? We can say, this cookie doesn't have time expiration, or it has months or years of expiration, right? So the server has to honor these old cookies, well, not old, that have been around. And that's how, Google or whatnot, right? It keeps you logged in for a long time, that they pass in this cookie, right? And it still remembers you. Now, oftentimes, it's expensive, again, to keep track of these session objects in memory in the server. So there are strategies where you can use virtual memory, right? Where now all this information is offloaded from the CPU, from the machine, from the computer, memory storage, and it's offloaded to the file system, right? Or even to a database, right? Where now we can store this session information in a database instead of in memory, right? So to make it more scalable, it's a little slower because you now you have to go to a database or you have to go to a file system as opposed to be in memory. But that's how Amazon or Google keep you signed in for months, right? You haven't had to log in Amazon for months. You just go there and it just works. It's because they have a long running cookie, right? That that is used to reinstantiate your session from a database, bring it into memory, and get you back in the database and bring you back to a state where you left off, a while back. And it might be that at that time we destroy that cookie, we give you a new cookie that again it's set up for for months, right? And till next time that you come back in, I'll give you a new cookie, right, which is set up for months. Okay. Anyway, that's all I had for you today. Let's see. Question. For storing information like items in a cart for a user, is it better to store it in a session or the application? No, so it's better to minimize what you store in the session, right? So at a minimum, we do need to store session information about my identity, who I am, right? So now I know who you are. I mean, you can store cart information in the session, but I wouldn't, right? The better place is to create records in the database, long-term storage, right? And just only use the cookie for identification. But the session is a hash table. You can literally store anything you want in there. But no, I would use a database instead. Right, exactly. Especially because eventually all that information needs to get to a database anyway. Yep. All right, anything else? All right, if nothing else, I'm going to call it a day. Thank you, everyone. Have a great Thanksgiving break. And I'll see you in about a week. All right, good night, everyone. Enjoy.